Imagine having theories for years together, just that no detailed evidence existed to back up these theories. Well, that is exactly what happened to the other solar systems in our galaxy. But the James Webb Telescope came to the rescue and has shown the world the Wasp 96b. Now, if you want to know more about that, please stay tuned. Hello guys, and welcome back to our channel. In today's video, we shall be taking a quick look at what the James Webb Space Telescope just caught, and this discovery is definitely going to shock you all. NASA's James Webb Space Telescope has discovered quite a few elements in outer space, which till now are just theories. Right from capturing haze to clouds in space, the James Webb Space Telescope has done it all. Furthermore, the telescope has also captured images of ambiguous water bodies on exoplanets that could mean that life forms could exist on these heavenly bodies. The James Webb Space Telescope comes with precision spectrographs and sensitive detectors that help detect these heavenly bodies that are found 1,000s of light years away from Earth. Furthermore, the infrared imager and slitless spectrograph that's found on the James Webb Space Telescope has helped detect a gas-like heavenly body that revolves around a sun-like star. The name that has been given to this gas-like planet is Wasp 96b, and this is the first exoplanet that deep research is being conducted on. Moreover, we can thank NASA's James Webb Space Telescope, as well as the discovery of Wasp 96b, as they have begun the amazing journey towards exoplanet exploration. This exoplanet is thousands of light years away from Earth, and being able to capture its presence was quite a big deal. To add to this, the telescope has helped study the various atmospheric conditions of the exoplanet by taking a look at the small reduction in the brightness of specific colors of light, which basically means that the gas that's present in the atmosphere here is made up of a certain type of molecule. The Hubble telescope was in the spotlight for quite some time before it was replaced by the James Webb Space Telescope. Speaking of the Hubble telescope, researchers and scientists have been using this telescope for almost 2 decades now to study the atmospheric conditions of heavenly bodies out of our solar system. But none of the results from this telescope was able to show as much clarity and accuracy as the James Webb Space Telescope does. The James Webb Space Telescope also is known to be faster than any other telescope, and finding certain planets and checking if it has life forms on it or is habitable is better performed by this telescope. Due to this telescope, it has been confirmed that there exist more than 5,000 exoplanets in our Milky Way. And amidst this, they were able to discover the Wasp 96b. So the Wasp 96b is said to have no counterparts as of now and is said to be around 1,150 light-years away from the Earth. The Wasp 96b revolves around another sun-like star and revolves around it every 3.5 Earth days. As for its location in the Milky Way, the Wasp 96b is found in the southern sky constellation, which many may know as PHEONIX. As we mentioned earlier, the Wasp 96b is quite puffy when looked at and is full of gas. It is quite different from the planets that are found in our solar system. It also has its mass half of what Jupiter has, and as for its diameter, it's said to be 1 or 2 times greater than that of Jupiter. As for its distance from its sun-like star, it is almost 1/9 the distance that exists between Mercury and the Sun. Due to this reason, it also happens to be quite hot. According to some researchers, the Wasp 96b is said to have a temperature of 1,000 degrees Fahrenheit on its surface. Thus, humans living there is next to impossible. Even though the Wasp 96b cannot be used as an abode for a human civilization, it does stand as a great body to observe and conduct studies on. As we know, space is vast and we have covered barely anything in terms of its exploration. There's so much to learn, and the Wasp 96b has just opened the doors for exoplanet exploration. The Wasp 96b has become a perfect body to conduct atmospheric studies and observations on, and with it being quite large in size and mass, studying its atmosphere as well as its orbital period would be quite beneficial. Furthermore, studies on the absence of contaminating light from nearby stars can also be studied here. Some of the most recent observations that were made by the telescope and are worth mentioning are the observation that NIRS made on the 21st of June, where they saw the Wasp 96b move across its star-like sun for a period of 6.4 hours. This created a light curve to be formed. This resulted in dim straight during the transit. Furthermore, the transmission spectrum depicts brightness variation of specific infrared light wavelengths between 0.6 and 2.8 microns. This is something that has never been observed through a telescope before, and it was quite a big deal to researchers and scientists. The atmosphere is vast, and to study it, we must delve deeper into its composition. Now with the tech that the James Webb Space Telescope comes with, it would help discover details of the atmosphere that we have not been able to find out for decades together. As we mentioned earlier, the light curve is formed. The light curve helps confirm quite a few parameters, such as the existence of exoplanets, the size of these exoplanets, and even details on their orbital path. In fact, prior to these results, most believed that neither water nor clouds existed on these exoplanets. But now with these results, it changes everything. The starlight is filtered by the atmosphere by the exoplanet right as it passes in front of the star. This is then compared to unfiltered starlight, thus creating a transmission spectrum. All this has been put into a graph for a better understanding of the observations made on the exoplanet. The graphs that are being drawn out by the experts are plenty. One particular graph has been taken note of the various features of the exoplanets, thus helping one to find out the very significant gases that can be found in the atmosphere of those regions. The atmosphere is filled with its own set of unique atoms and molecules, and all of them have their own unique pattern of wavelengths that they absorb. Studying these helps understand a lot about the functionality of the exoplanet as well as backs up why it does what it does. Not so long ago, the Wasp 96b spectrum was observed by the James Webb Space Telescope, which is known for its accurate results on its near-infrared transmission spectrum of an exoplanet atmosphere today. This also includes taking a look at the various wavelengths that come along with it. These would include regions such as visible red light. This would also help discover inaccessible spectrums that have been observed vaguely by other telescopes. Just like how we look for carbon dioxide, water, oxygen, and other important gases on planets in our solar system, scientists have been looking for the same on these exoplanets as well. Apart from finding out if these constituents exist on them, they'll also be able to find out the amounts of it present on these planets. For instance, they will be able to find out the exact amount of water vapor in the atmosphere of these exoplanets. The various constituents of the atmosphere, such as whether it contains oxygen, nitrogen, or carbon dioxide, will also be derived. As of now, the James Webb Space Telescope is being used to observe the temperature factor of these exoplanets. Finding out this would help understand the exoplanet's overall composition as well as how it came into existence. Now, before we forget to mention, the telescope comes with a 270-foot gold-plated mirror that's known to effectively capture infrared light. This component comes with sensitive infrared detectors that help detect minute variations in brightness. Furthermore, its precise spectrographs disperse light into rainbows of thousands of infrared colors that further help in the study. The NRSS, which is part of the telescope, helps distinguish between the brightness differences between the colors that are a few 100 parts per million apart and colors that are only a few 1,000th of a micron apart. It also helps cover infrared wavelengths that other telescopes were not able to discover. Moreover, the infrared nature of exoplanets has been studied vaguely by other telescopes, but with the James Webb Space Telescope at hand, the level of detail in the findings has increased by a large magnitude. And that's all for today, and we hope you enjoyed our video. Drop this video a like, subscribe to our channel, and turn on your post notifications to receive the latest updates from our channel. Bye and see you soon!